Endo and exothermic processes are any that are gaining or losing heat for our system relative to its surroundings. So that could just be something that's going up in temperature or down. It could be something that is melting, boiling, subliming, freezing, etc. But in chemistry, we are often involved and interested in the chemical changes that are occurring to make that happen. The breaking of bonds, and the more we see here and think this, the better. Breaking requires energy or is an endothermic part of the process, and making bonds releases energy and is an exothermic part of the process. But overall, we are often looking at just the reaction as a whole. Does it release or absorb heat? Enthalpy is the type of heat that we're often talking about when we are looking at heats of reactions. It's the sum of the internal energy and any pressure volume work, or really enthalpy for our purpose is the heat exchanged when we're in a constant pressure system. We don't need to worry anything beyond that other than to recognize that Q and delta H are related, but often delta H is what we think of per mole, whereas Q is just that total amount heat gained or heat lost. The units help us to know that, and sometimes we'll even think about a difference of a Q in terms of joules versus a kilojoules. But what it comes down to, and this is a very important summary here, is what is happening to heat and how can we experience or feel that, and then connect that to an explanation. It doesn't like the fact that I have a subscript here and I'm making up a made-up word, but we're dealing with it. But an exothermic reaction is one that releases heat to the surroundings. That means that the heat exchanged, it has lost heat to the surroundings. My system now has less heat. That's why an exothermic reaction would always have a negative sign on its delta H. But because we're often measuring the temperature of the surroundings, the thermometer itself is a part of the surroundings. It is not the reactant nor the product. It is not the bond made nor broken. It is a piece of metal or glassware that is touching those things. By definition, the surroundings. It ends at a higher temperature, or it goes up because the surroundings are gaining the heat that is being released. That's why it feels hot, because the surroundings are hotter. And when your hand touches it, your hand is the surroundings. Endothermic absorb heat from the surroundings. They require more heat than is released, or heat has to flow in. The delta H is positive because the heat is now, or the energy, there is now, more energy in my system than there used to be. Energy that used to be in the surroundings is now a part of my system. So the surroundings have lost some heat and they feel cold. Your hand, when you touch it, is actually giving heat to the reaction itself. That is one of the sources of the heat that's being absorbed by the reaction. So we need to be very careful. There's not necessarily an equation that's going to show us to change the signs here, but we're going to see when we do these problems. And these are important problems to practice. We'll do them in labs, we'll do them online, we'll do them on quizzes, but it's important to see here the units and the sign, how those come into play, very much so.